Okay, here are a couple more examples of separable differential equations. So here we want to solve the differential equation dy dx equals x times y times e to the x squared. Okay, so first separate, get all of the y's on the left side and all of the x's on the right side. And then we're going to integrate each side. The left side is going to give us the natural log of the absolute value of y. To integrate the right side, we're going to need a substitution. Plugging in for x squared and for dx, we get x times e to the u times du over 2x. The x's will cancel. And we end up with 1/2 e to the u plus a constant c. Now, you'll notice on this example, I've only written the constant on one side. In reality, what happens is that both integrals produce some arbitrary constant. I'm simply moving those constants over to one side and then calling them c. You'll need to solve by exponentiation. Take e to the power on both sides. We're going to get absolute value of y equals e raised to the 1/2 e to the u, which remember is now x squared plus c. And again, because e to any power is always positive, we can drop the absolute values, and our final answer is y equals e to the 1/2 e to the x squared plus some constant c. Here's another example of an initial value problem that involves a separable differential equation. First, separate, and then integrate each side. So on the left side, you need to recognize that as the inverse tangent. So the antiderivative of dy over 1 plus y squared is inverse tangent of y. And the right side is just a straight power function, more or less, so anti-differentiate that, gives you x plus x cubed over 3, and again you'll need to have a constant c in there. Okay, now we're going to solve. So this ends up being y equals the tangent of x cubed over 3 plus x plus the constant c. Use the initial condition given to figure out what c is equal to. Put 0 in for x and 1 in for y. This ends up being 1 equals the tangent of c. And thus c should be pi over 4. So finishing this off, the final answer is going to be y equals the tangent of x cubed over 3 plus x plus pi over 4.